Hey guys, my name is Shreyas and welcome to Simple Chemistry. Today we're going to be talking about binary ionic compounds. As you can see here, it's important when we're talking about nomenclature, to identify the type of compound we're looking at even before we start naming them. In the previous lesson we talked about binary covalent compounds. We're going to be looking at something which is pretty similar but has different rules on how we name them. So let's first discuss what a binary ionic compound is. A binary ionic compound is a compound which has two elements, hence the binary, and those two elements, the first element is a metal, which is any element on the left side of the zigzag line of the periodic table. Okay, that's the first element, and then the second element is a nonmetal, which is basically an element on the right side of the zigzag line. Okay, so metal plus nonmetal is a binary ionic compound. The way we name these is we first name the metal, and then we name the nonmetal with the IDE ending, and then here's the little difficult part. We use Roman numerals for transition metals to specify oxidation states. We've talked about oxidation states on our video in bonding. It's important that you probably go back and watch that video on oxidation states if you don't know what an oxidation state is. But basically, whenever we have a binary ionic compound, and that binary ionic compound has a metal, which is a transition metal, and a transition metal is a metal which is in this section of the periodic table, this section of the periodic table right here. Okay, not in these columns, in this section of the periodic table right here. Okay. Whenever we're talking about those elements, those metals tend to have more than one oxidation state. Okay. And since they have more than one oxidation state, or essentially more than one charge, it's important to specify that charge. And the way we do that is with Roman numerals, and I'll go ahead and show you that in a few examples. But let's just go ahead and do a few examples so this makes sense. Okay, so let's look at our first example over here. Let's first make sure that this is indeed a binary ionic compound. So the first element is sodium. Sodium is right here, which is to the left of the left of this zigzag line. It's right here. So that is a metal. Sodium is a metal. And then we have chlorine, Cl, and chlorine is to the right side of the periodic table. So we have a metal plus a nonmetal, and this is indeed a binary ionic compound then. So how are we going to name this? So we name the metal. All right, so let's go ahead and name it sodium. Now this is important here. We have to, when we're naming the metal, we have to check for Roman numerals, because if the metal is a transition metal, then we're going to have to go and use this last rule over here. Okay, but the thing is, sodium is not a transition metal. Sodium is right here. It's not in the transition metals, so we don't have to worry about our third rule right here. So we can just say sodium, because sodium will always have a +1 charge. If this does not make any sense, please again go watch the oxidation video on oxidation states, which I'll link to YouTube. But since sodium always has a +1 charge, we don't have to indicate the Roman numeral. Okay, so we can just say sodium, and then we write the nonmetal with the IDE ending. So chlorine, instead of saying chlorine, we're going to say chloride. Okay, pretty easy. Next one. Okay, let's first again make sure this is a binary ionic compound before naming it. We have copper. Copper is a transition metal. It's right here. It's in this middle section of the periodic table, so it's a transition metal, which means we're going to have to use Roman numerals to identify the oxidation state. Okay, and we had oxygen here. Oxygen is a nonmetal. It's on the right side of the periodic table, so we have metal plus nonmetal. So this indeed is a binary ionic compound. So what we're going to have to do here is, since copper right here is a transition metal, and again, the way we know it's a transition metal because it's in the middle of the periodic table, since it's a transition metal, we're going to have to write the oxidation state. Okay, and that oxidation state, we're going to have to figure out the oxidation state of copper in order to write the name of our compound using this third rule right here. So let's identify the oxidation state. We know that oxygen always has a -2 charge. Let me write this, expand this, see. So we know that oxygen always has a -2 charge. And all compounds are electrically neutral, so that means the copper has to have a +2 charge. So when we name this, we're going to have to name it like this. We're going to have to write copper, again, because our first rule says right here, name the metal. But then since copper is a transition metal, we're going to have to specify the oxidation state using Roman numerals. So since the oxidation state of copper is +2, we're going to have to write like this with Roman numerals, 2, like this. So copper, and then with parentheses, 2, okay, because that's the oxidation state of copper. And again, copper is a transition metal, that's why we're doing this. And then we're going to have to name the non-metal with the IDE ending. So that would be oxygen would turn into oxide. Okay. So just to recap, if our metal here is a transition metal, we're going to have to identify the oxidation state of the metal and then use Roman numerals like this in order to specify the oxidation state. Okay, and the Roman numerals are like this. You write the Roman numeral for the oxidation state, and then you put it around parentheses like this. If the metal is not a transition metal, so those would be metals which are in these two rows right here. If the metal is not a transition metal, then we don't have to write the this Roman numerals. For example, sodium is not a transition metal, so we don't write the Roman numerals. Hope that makes sense. Let's look at our next example over here. This is first thing first. Let's make sure it's a binary ionic compound. Our first metal here is manganese. Manganese is indeed a metal, and because it's to the left of the zigzag line, and it is a transition metal because it's in this section of the periodic table. So we know we're going to have to use our Roman numerals to identify our oxidation state. And then we have oxygen right here, and oxygen is a nonmetal, so we have metal plus nonmetal, so this is a binary ionic compound. The reason I'm doing this is because whenever you get your nomenclature test, your teacher's probably not going to tell you if it's a binary ionic compound or a binary covalent compound or another type of compound. You're going to have to identify that, so it's important that you identify the type of compound that you're looking at before you name it. All right, so we have this. Now, since this manganese is a transition metal, we're going to have to identify its oxidation state. So let's go ahead and do that. Let me erase this. We have Mn2O3. We know each oxygen atom is always going to have a -2 charge. So since there's 3, the overall charge of the oxygen atoms is a -6, which means there has to be a +6 charge to balance that out. Since there's 2 manganese atoms, we're going to divide this by 2. So each manganese atom has a +3 charge. So when we write this, we can write manganese. We name the metal, so that's manganese. Again, if this thing made no sense, watch the video on oxidation states, please. So manganese, then we know that the oxidation state of manganese is +3, so we're going to have to write that in our Roman numerals right here. So parentheses, 1, 2, 3 in Roman numerals, close parentheses. And then name the nonmetal with the IDE ending. So that would just be oxide. Sorry, this is starting to get messy. Let me erase this. Rewrite that. Oxide. Okay. Let's look at our next example here. This is, again, let's ensure it's a binary ionic compound. We have 2 elements. First one, cadmium, is cadmium is right here. Cadmium is right here. So it is a metal. And then we have fluorine. Fluorine is the right side to the zigzag line. Fluorine right here, so it is a nonmetal. So we have metal plus nonmetal. So we know for a fact we have a binary ionic compound. So let's go ahead and name this. We have to name the metal, so cadmium. Name the metal cadmium. Now, here's an important thing that you need to know. We're not, even though cadmium is in this little box right here, cadmium is right here, right? So even though it's in this little box right here, we're not going to use Roman numerals for it because cadmium in any compound has a +2 oxidation state. And I mentioned this in the oxidation states video, but cadmium is always going to have a +2 charge, okay? +2 oxidation state number, oxidation number. And silver is always going to have a +1 oxidation number. Zinc is always going to have a +2 oxidation number, and aluminum is always going to have a +3 oxidation number. Okay, so silver +1, cadmium and zinc +2, and aluminum +3. Okay, because of that, we don't ever write cadmium 2 or zinc 2 or silver 1. Okay, we just say zinc, cadmium, silver, and aluminum. We never write the Roman numerals because they only have one oxidation state. Just like these metals right here have only one oxidation state, silver, cadmium, zinc, and aluminum only have one oxidation state. So whenever we see them in compounds like this, we're never going to say cadmium 2 fluoride. We're just going to say cadmium. Okay. So cadmium. And then we're going to name the nominal with the IDE ending, so that will be not fluorine, but fluoride. Okay, and we do not, again, let me emphasize this, we do not use a Roman numeral because for silver, cadmium, zinc, and aluminum, you need to memorize this, we do not use Roman numerals because they all have one oxidation state. Silver always has a +1 oxidation state, zinc and cadmium always have a +2 oxidation state, and aluminum always has a +3 oxidation state. Okay, so we just say cadmium fluoride. We do not say cadmium 2 fluoride. Now let's go the other way. Magnesium chloride. Okay, now let's write the actual, what the compound is. So magnesium is here, and again, oxidation state is very important. So we know that since magnesium is in this row of the periodic table, it always has a +2 oxidation state. Okay, and then chloride, so that's chlorine. You know, chlorine, when it's in a compound, it's going to always have, since it's in this row this column right here, it's going to always have a -1 oxidation state. So we have to do this interesting thing here. So magnesium has a +2, and the chlorine has a -1. So that means there has to be 2 chlorine atoms to balance out the charge, since compounds always have a neutral charge. So if there's 2 chlorines, the overall charge will be -2, which will balance out with the magnesium, and then that's our compound. So MgCl2. Okay, it's working backwards. So magnesium chloride is MgCl2. Let's look here. Nickel 3 sulfide. So we know that our nickel here, I'm going to write this in a different color. Nickel here has a +3 charge, and our sulfide, since sulfide is sulfur, it's in this row right here, which means it has a -2 charge. Okay. So whenever we have charges like this, actually I should have just done it right here. So this is a cute little trick. Okay, so when you say magnesium chloride, if you want to find the actual numbers of the atoms, we just flip. Okay, flip. So we see here, since chlorine has a -1 charge, the number of magnesium atoms is 1. Since magnesium has a +2 charge, chlorine will have 2. So same thing here. Since the sulfur has a -2 charge, there will be 2 nickels. Okay, and then since the sulfur has a +3 charge, let me restate that. Since sulfur has a -2 charge, there will be 2 nickels, and since nickel has a +3 charge, there will be 3 sulfurs. You just kind of flip the numbers. So nickel 3 sulfide is Ni2S3. Last example here, zinc chloride. Now, special thing right here, we said that zinc always has a +2 charge. I'm going to emphasize that again. Silver always has a +1 charge. Zinc and cadmium always has a +2 charge, and aluminum always has a +3 charge. So zinc chloride, that means zinc, let me do one last color here. So zinc has a +2 charge. Chlorine has a -1 charge, so we can flip the numbers. So zinc, there's only one zinc because the chlorine has a -1 charge. And the chlorine, there is going to be 2 chlorine atoms because this thing has a +2 charge. Again, just flip. So zinc chloride is ZnCl2. Okay, I know this is kind of long, but make sure you do the practice quiz that's attached to this video so you can master this concept. But that's it for now. Binary ionic compounds are as simple as that.